You've heard of masking an image, but today we're going to do the exact opposite and we're going to make a reverse mask, otherwise known as a hole. We're then going to take our new hole and we're going to use that to make an animated menu bar. If you want to see the original tutorial in Figma where I got this idea, I'll leave a link in the description. The interesting thing that we're going to do here is we're going to map the UV values from the world coordinates so that our mask can be specified in pixel values, and then our shader takes care of where to put it, and our hole will just work, even with rotation. Now, that's all going to be solved with a transformation matrix, and I'm going to show you guys how to use that. In the end, it all comes down to just inverting the mask, multiplying the alphas, and drawing it on the screen. I'm using Unity 6.3 and SRP. First thing I'm going to do is I'm just going to make a blank panel. That's going to be our holder for everything that we're going to do. So if we move things around, everything else moves around too. We don't need the image it comes with. Just remove it. We're going to be adding another image. This image is going to be the holder for the big menu bar area. And then we're going to have another image that we're going to add. That's going to be our selector, which is that circle that we had. The circle is going to move around, and then our mask is going to follow underneath the circle, so it looks like it's cut out and warping. But we know it's just a mask. But the person playing the game will think it's warping or doing something cool. I like to change the background color of the camera from the skybox for this kind of thing. Pick a nice color. I'm going to go with a gray, like millennial gray. Now we could do a similar effect if without a shader, if we just pick the right background color for our camera and the right background color for our selector, and the thing becomes sort of invisible. You can move it around and it gives you sort of a similar effect where it disappears. But what happens if you change anything else about the scene, like the background changes or the color changes? That effect is going to really quickly fall apart. I'm going to now jump over to Figma and make the shapes that we're going to use in the tutorial. I really like when the tutorials include all the steps and show you how to do everything. So we're going to do that. I'm just making a rectangle. I made it 600 by 100, and we're going to add a corner radius so it looks a little smoother. Let's preview what it looks like in the black background color that we're going to be using in the Unity engine. Now, we're not going to keep it that color. We're just doing it for looks. We're also just going to make a little circle selector. You could make any shape, but this one's just going to be a circle because we're trying to recreate that same effect that we saw in the other Figma tutorial. Now we also need to make the mask shape. The mask shape is just made by another sphere, and we're going to just change some of the properties of that sphere using the handles for the vector. And that's going to allow us to make this nice little rounded shape that looks like a cutout. We'll rearrange some of our pieces so that they're in the right order. And if you go ahead and you double click on this little second circle that we made, it's going to let you mess with the handles. And we're going to need that because we want the handles to look more round, so it looks like it's morphing into something as we move it around. I'm just going to go ahead and play with the shape until I'm happy with it. We'll export it to Unity. By the way, all these project files are just going to be available in the description, so if you don't want to make all this, you can just download the project. Something I like to do here is export everything in white, and the reason is in Unity, you can change the color later, and you're not stuck with whatever color you pick if you choose white. Now, before we're completely done, we need to take our mask image and we're going to add just 1 pixel of transparency all the way around it. And that's going to prevent an issue in the shader called edge bleeding, where the very edges of it, if they're not transparent, are going to bleed out and make this big T-shaped cutout. And by adding 1 pixel of transparency around it, we can avoid it without complicating our shader. In Unity, we're going to take all our textures and make them into sprites. Unity is nice enough to say, hey, if you don't have the 2D sprite package, you probably want it. Go ahead and click this button and it'll go ahead and add the package to your project. Now we're going to go ahead and take our rounded rectangle that we made and we're going to just drag these edges down in single sprite mode. And this is going to allow the image component to 9 slice our image so that rounded corners stay rounded, and it's going to expand that middle part out. And because it's all white, it's going to look great. Now let's set the sprite on our image mask, and we've got our rounded corners. We can change the colors because our original sprite was white, and this color lets us change the color later. We'll go ahead and set the selection to the circle, and we're also going to play around with the mask. I'm just going to set the mask as the same color as the background so we can get a preview. This is not how we're going to use the mask. Now, if the mask color and the background color are the same color, they disappear. But look, when we change the color of the background on the camera, the effect is gone. We have to fix this by making it transparent, and that's where we're going to make our reverse mask. So delete that image, and let's go ahead and make a shader. We're going to use shader graph to make this shader, and we're going to make it from a canvas shader. Now, the one limitation to using shader graph is you can't use stencil buffers, but that's okay because we don't need stencil buffers to do this effect. Let's first hook up the image and just test that functionality. We need a sample texture 2D node, and if we go ahead and add a property named main text, the image and our shader will work together, and that image will come through as main text. It has to be named that. It's just a reserved word. But if we do this and we go back and test it, we won't see any change, and that's a good thing. That just means it's working. Now let's add our mask texture. We need another sample texture 2D node, and then we need a node to subtract 1 from the alpha. So it's going to be a 1 minus node. And what that's going to allow us to do is make the exact opposite of our mask so we can have a hole. Then we can combine the 2 alphas with a multiply node and put that into the alpha of our fragment shader. Let's look at that. So we've got a funny shaped hole. It's not scaled right, but that's okay. That's the next step. We're going to change the world coordinates that we want it to be into the UV coordinates that it needs to be. We need to take the world space position, split that, put that into a vector 4. Now this vector 4 only has the 2 components, the x and the y, and the last needs to be a 1 for this matrix multiplication to work. We need to create a 4x4 matrix that we're going to feed in from another script later. That's going to be our rotation, scale, and translation. And then we're going to take that result and map it into the texture for our mask. I've added a new class with the attribute to execute always. And we need the interface iMaterial modifier. And that's going to allow us to get the material that's modified so we can change properties about it so that every material that we have in Unity can be slightly unique, so we don't have to make a new material every time for each type of menu mask combination that we want to make. So we can have multiples of them. Now let's add our serialized private fields so that we can test this in the inspector. Now every time we change something, we want our material to be set as dirty. We're going to add some properties so that we can test this in the inspector, and it's going to set it dirty for us every single time we change something. Now we can get our modified material. We're going to cache this so we don't have to call it every single frame. And then we're going to apply properties to that material every time something changes. We'll convert our sizes into a mapping from 0 to 1, then offset the mask's top left corner. Now we create a matrix with helper functions that converts our world space into normalized mask UV space. We got to scale it, and then finally combine the world to local matrix, which also includes the rotation, and then send that result to the shader. Now we can finally play with the values in the inspector and see our masks show up. You notice that when you switch to game view, the shader doesn't show up. That's because we have to change another setting. Select our canvas and change the render mode from overlay to screen space camera mode. That's going to let our shader do the correct mapping. Now we need to just adjust the offset pixels for our shader. If you notice that the scene view and the camera view is backwards, we just need to change which side we're viewing on the editor in the scene view, and everything will look normal. It'll look as if it looks through the camera. Let's add another script called follow with offset, in which the selector will now move around and the mask will follow that selector. Add the execute always attribute so that we can see this running in the editor without it actually running. Back in Unity, we can now set our target as the selection and then play with the offset. And then when we move the selector, the actual game object, we'll notice that our mask now follows it around and it kind of looks like it's warping. But not only does it just follow the translation, it will also follow the rotation, which I haven't seen a lot of mask shaders do, which I think this is kind of a nice touch. Now, to complete this effect, we really need to add some buttons so that this is interactive from the player, or whoever's using it, so that when they click in the area, we want that little selector to move around, like it did in the Figma tutorial. We're going to add a panel with a horizontal layout component so that when our buttons are lined up, they just happen to, you can have as many buttons in there as you want, and they're just going to arrange themselves nicely. I'll just speed this up so I have 4 buttons laid out nicely, and then I'll show you how to hook up the animations so that the buttons sort of move when you interact with them. I've replaced the text for the button with an image here. I'll just record an animation for when the pressed event happens, and we're just going to move this up, and we're going to change a little bit of the color here. So to set the first starting key, I would like to change like the Y position and then set it back so it gets recorded as 0. This is going to be all relative to where the button is. It's not going to be in world space, it's all in local space. So I'm going to raise it up, and then I'm going to set a color. I'm going to copy those animation keys into the selected animation, and then we're going to go ahead and test it out. Now, we want to be able to push the button and have our selector move to that location. So we're going to select the panel, the very parent that everything is under, and make a new script called move. So we're going to fill this out with a function called update position that takes the transform. This is the function that's going to get hooked up in the inspector that the button's going to call with its own transform. And then we're just going to run this in the update function so that it's animated in a very simple way. We'll add our round selector game object to the selector in the inspector. Then we're going to hook up our button to call the function on the panel with our own transform. Let's try this out, push play, and then in the game view, click the button, our selector moves to the button's location. Now we just duplicate the button a bunch of times. Let's try this again and try clicking on different buttons, and our selector should be able to morph onto every single button. Like you can see on this little example that it's a little bit too close to the edge, so we might want to adjust our margins a little bit. But I hope that you get the idea of this effect. We really quickly made a shader that does the inverse mask, and then we applied that, and I hope this is a technique that you can use in your own games. Project and all its source code is in the description below. And if you have any comments, leave them below. I'm happy to answer any questions or discuss making a video on something that you would want to see. Other than that, have a great day.